Sting. Alright, this is Sting's brain. It's the VEX EDR cortex. This is Sting's battery. And these are wheels. Let's go! You're going to start by plugging in one end of your USB cord into the computer and the other end into Sting's brain, like so. Open up RobotC on your desktop, and we're going to begin by setting up our coding environment. And we're going to start by letting the program know how we're going to be downloading the code to the robot. In case you didn't know, to navigate Sting through the course, we're going to write a series of commands that are equivalent to go forward, turn, etc. And when we download them to Sting's brain, the brain's going to store the commands and then complete them when we turn them on the course. So the way we're downloading the code onto Sting is with the USB cord. So when we scroll over to robot communication type, we're gonna pick USB only. This way it's all clear, the computer knows how we're communicating. Okay, real quick, these are the two motors that drive the left and the right side of your robot. They have wires that are plugged into ports on the brain, so these are plugged into ports 1 and 10. What we're doing next is basically telling the computer where the motor cables are plugged in so it knows where to send the power! So let's open up motors and sensors and go to motors, and this is where we'll tell the computer where the motors are plugged in. So it looks like left motor plugged into port 1 and right into port 10 on the brain. Where it says port 1, I'm going to name my motor left motor, and in port 10, right motor. The type of motor we're using are VEX 393 motors. And now I'm going to reverse the left one, meaning whenever we tell it to go forward, it'll actually go backwards. And that might seem really weird at first, but it actually makes sense if you think about it. So to the robot brain, forward means spin the wheel clockwise. Now, clockwise for the right wheel makes it spin forward. But if you turn it around and look at the left side, clockwise is actually backwards for the left wheels. And then this way, when we say go forward, both sides will actually go forward. So now we're going to save it, and we see up here that 2 lines of code have been generated. Yay! They're basically telling the program where each motor is plugged in, which ones were reversed, etc. So the code is all clear. Okay, now let's get to the real coding. So the code you'll be writing to tell your robot how to move will be right in here. This is called, okay, so this is your main function, or it's the main part of your code. Between this curly bracket here and this curly bracket down here. So, okay, here's how to go forward. We're letting the computer know that the motor we call left motor is going to spin at full power and always end your line with a semicolon. That's how the computer can tell that you're finished with that particular command. 127 is full speed ahead, 0 is still, and negative 127 is full speed backwards. For the course, I set it at about 80, so I don't end up ramming the sides. Now, we're gonna add that exact same line. You can just copy and paste, except it's gonna be for the right motor. We have both motors spinning forward, but we wanna limit the amount of time that they're spinning forward so that we can stop and turn and then do the next part of the course. So this command, called wait 1 msec, or millisecond, will determine how long the wheels spin for. So 1,000 milliseconds is equivalent to 1 second. So if I wanted to go forward 5 seconds, I'd enter 5,000 milliseconds into the command. Now we need to stop the robot after the wheels spin for that amount of time. So I'm gonna copy and paste both of these commands, but I'm gonna set the speed to 0. This way the motors are gonna stop running after 5 seconds, or however long you put in there. I'm gonna put a wait command after this chunk of code so that the wheels have time to slow down and come to a complete stop before they turn or do their next command. To turn, you can just copy that whole chunk of code there and modify one of the values so it's negative. The computer will read the negative value and make your robot wheel turn backwards instead of forwards. So if you want your robot to turn right, you're gonna make the right side negative, and if you want the robot to turn left, you're gonna make the left side negative. At some point you'll have to figure out how much time for a turn gets your robot to a 90-degree turn, because that's what you'll need for Rainbow Road. One last thing, I like to put a 1-second pause at the beginning of my program so that you have time to pull your hands away after you start the code. And when we run the code, the robot's literally gonna read these commands in order from top to bottom. So real quick, I'm gonna name and save my project in case the computer goes crazy. And now I'm gonna test my code on Rainbow Road, but I'm gonna test it in little sections. So I'm starting with perfecting this first stretch and turn before I move on to the next part. I'm gonna make sure my robot's plugged into the computer and then I'm gonna hit the download to robot button. And if you ever get the notification that your robot needs to power cycle, just unplug it, make sure it's off, unplug the battery, which Greta can help you with because it's hard, then plug everything back in, the battery and the cord, and just re-download the code. And then once it's done downloading, you can set it up on the course and line it up in a way that you'll remember. You can use tape or something, and then you're gonna turn the robot on, and the robot's automatically gonna run the code that you've downloaded once you turn it on. Then just see what changes need to be made, make the changes in the code, like if it needs to go forward more or less or turn more or less. Let's go, team robot.